NASA has been putting a remarkable new rover through its paces, and this little machine could play a huge role in the future of space exploration. Engineers at NASA's Jet Propulsion Laboratory recently sent a four-wheeled prototype called ERNEST into California's Colorado desert for a challenging field test. Over 37 hours of driving, the rover covered around 16 miles completely on its own, handling route planning and avoiding obstacles without human intervention. The team stayed close by to monitor its progress, but the rover was allowed to make its own decisions as it traveled through daylight, sunset, and even complete darkness. The goal was to see how well the technology performs in conditions that are similar to what future missions could face on the Moon and Mars. ERNEST, which stands for Exploration Rover for Navigating Extremely Sloped Terrain, was built to tackle a major problem that current Mars rovers struggle with. Existing rover designs can usually handle slopes of about 15 degrees before they start losing traction or risk getting stuck in loose soil. ERNEST was designed to push far beyond those limits. Development on the rover began back in 2022 with funding from JPLs, and later received support from NASA's Mars Exploration Program and teams focused on future space missions. Even though ERNEST is only about a quarter the size of another experimental rover called Endurance, it carries some very advanced technology that could help future missions explore crater walls, steep hillsides, and difficult terrain on both the Moon and Mars. One of the most impressive features is its active suspension system. In normal mode, ERNEST behaves like a regular rover, keeping all four wheels on the ground and driving across rough surfaces with ease. But when conditions get tougher, the rover can switch modes and redistribute its weight, raise individual wheels, and even wiggle itself free from sandy traps that might have ended the mission of an older rover. The system has already proven capable of climbing slopes as steep as 35 degrees on loose terrain, designed to mimic the Moon's surface. It can even crawl over obstacles that are nearly as tall as its wheels. ERNEST also features 4 independently steerable wheels, giving it incredible maneuverability. It can make sideways movements and escape tight situations that would challenge many other rover designs. Its wire mesh wheels are particularly effective on difficult ground, providing extra grip where traditional wheels might struggle. Another major advantage is its autonomy. The rover carries all of its computers, sensors, and controllers on board, meaning it doesn't need constant instructions from Earth. That's incredibly important because future missions to the Moon and Mars can't rely on real-time driving due to communication delays. During the desert trial, engineers simply gave ERNEST a planned route and let it do the rest. The rover successfully avoided hazards and kept moving even as lighting conditions changed and long shadows appeared, similar to those found near the Moon's poles. Covering 16 miles in just 37 hours of driving is a significant achievement. That's already much farther than the cautious daily distances typically covered by current Mars rovers, and offers a glimpse at the faster, more capable robotic explorers NASA hopes to send into space in the future. Perhaps most impressive of all, ERNEST managed speeds of up to 1 kilometer per hour, even while dealing with steep slopes and rocky terrain. It may still be a prototype, but this little rover is showing that the next generation of planetary explorers could go farther, move faster, and reach places we've never been able to explore before.